Welcome to the first course on cloud computing. This is an introductory course which will tell us what is the motivation behind doing a course on cloud computing. We will also see that what the industry is saying and how the industry is predicting where cloud is going. So, cloud computing is considered to be a phenomena. It is growing at a pace which is very phenomenal, and we need to really understand what the cloud computing is becoming into. As Gartner says that the use of cloud computing is growing, and by 2016 this growth will increase to become the bulk of new IT spend. Gartner being a big IT company which definitely predicts a lot of new things that is going to happen, this looks to be a very promising and important consideration, and we are going to see why Gartner makes this prediction. This slide shows the trend in cloud computing. In 2012, we see that the number of subscribers of cloud storage was approximately 500 million. By 2015, we see that the number has grown to a phenomenal number of 810 million, and another 2 years we were seeing that this growth will become 1300 million. So, from 2012 to 2017, in 5 years, we are seeing almost a 3 times increase in the number of subscribers in cloud storage alone. Besides cloud storage, we also have other phenomenon in cloud computing which people subscribe to. So, we can readily understand that if this is the growth only one small part in cloud, then the overall growth of cloud is definitely a big motivation for us to learn and understand what is there in cloud computing. So, before we go into that, let us look at how the cloud has evolved. Look at the computing technology. Over the past 60 years, the computing technology is going through a lot of change. It is changing everywhere. The change we see in the machine architecture, we see changes in operating system, we see changes in networking, and definitely in application workload, which means how the applications are being developed and used using a cloud. However, whenever we talk of these kind of changes, the change does not only have one-sided effect, it also has a reason to make us think where we are going, because the scalability part, as we grow, as many more people start working with the cloud or with the computer infrastructure, we have to see that our infrastructural growth also should be enough to accommodate so many people who are coming into the cloud technology. So, the scalability is the problem of how to resolve the growth, how to contain the phenomenal number of people joining in the computing scenario. So, we look at it from two perspectives, that how we are going to contain the growth from the perspective of paradigm, and from the perspective of paradigm we need to look at how to solve this large scale problem over the internet. The number of growth of internet user is very large, and people are becoming more data intensive and network centric. But before we get into the internet, first let us look at how the generations of computing has evolved over a period of time. So, in early days, people used to have a pebble on a clay board to calculate additions and subtractions. That used to be their machine using which addition subtractions would be calculated. In 3600 BC, abacus was invented in China. that was the first computing machine that was invented, but we have come a very, very long way from that, and we see that the first proper computer was given in 1940. Approximately we can divide the generations into 10 to 15 years, with the first generation starting in 1940, spanning about 16 years. In that time, vacuum tube was the mechanism using which the computers will be created, and for memory they used magnetic drums. This made the computers very large, so they would fill one complete room, and therefore we needed to have a very large energy consumption, electricity consumption. Therefore, there would be a very large heat generation problem. The language on which these machines used to depend was machine language, which means that it was zeros and ones. An example of such machines was UNIVAC and ENIAC. In the next generation, we came to the generation of transistors, where the transistors were used to create these computers. The symbolic language replaced machine language, which means that the programming became a little easier for the programmers. Even this era saw the beginning of high level languages, which is COBOL and Fortran. Of course, very early versions of COBOL and Fortran, but high level language concept came during this time. The first of this era could store instructions in their memory. So, this is the first time that memory could store instructions, and these instructions would be brought to the CPU to be executed. In the next generation, which started in 1964, the integrated circuit concept came. We know that ICs became very popular after that, and the transistors actually were made smaller and put in a circuit board and used for as part of the motherboard. The keyboard came and monitors came. So, this made interacting with the computer much easier, and as we can see from the size of the computer, this is the current size of computers approximately that we see. So, modern computer, we can say that started in this third generation, where we have looked at computer as they are basically today. The operating system came during this time, which means that directly writing programs and running on the hardware would not be required anymore. We can use the operating system, and the operating system would manage the programming environment inside the hardware. This is the generation where the concept of application started, and therefore different applications were being written. High level language came in very properly, and the third generation computer actually is the computing environment where the modern computer came in. Then comes the fourth generation of computer. This is the actual modern generation of computer, the generation of microprocessors, where we have thousands of such integrated circuits built into one single chip. And the major phenomenon in this generation is the development of GUI. The user's interface, the graphical user interface has started in this. Mouse came in. Other handheld devices were invented during this generation or this era. The prime example of this era is Intel 4004 chip, which was made part of a component of a computer. The next generation, which is the fifth generation, this is also the current generation, and as we can see in the diagram, this is our modern computer that we are accustomed with, with proper appropriate monitor, etc. The change that happened from the fourth generation is basically how we interact with the computer rather than what is happening inside the computer. We started using the concept of artificial intelligence, which means that we have learned how to make the computer a little bit intelligent. We still have a long way to go. This era has not finished yet. So, this is a very long era that is going on. We learned how to do parallel processing, thereby making our time of computing much less than what it used to be in the earlier era. We learned how to use superconductors, thereby making the heating and other problems a little less. Our devices now started responding to natural language, which means that we have learned how to teach the computer how to understand natural language. So, therefore, our computers became capable of learning. Another phenomena that happened is the self-organizing. The self-organizing part of computers started coming. Therefore, special applications proliferated during this generation. We see many new applications that have come in. Perhaps the most important such application is the voice recognition. We all are aware of the Apple voice recognition mechanism called Siri. It can actually recognize our voices absolutely properly. So, when we look at the evolution, we see that evolution happened everywhere. It is not only in the computing or the way in the computer insides, it also have happened in other areas, which is basically the internet and the various paradigms that we have been using. So, let us look at internet. How the internet have grown is perhaps an unprecedented growth in the history of computer. We need to provide service to billions of users who all the time will be connected to the internet, through internet to each other, and therefore managing internet users, giving in to their demands, ensuring that the internet users are taken care of became a very serious concern. There are two ways we could have handled this. People started using supercomputers, which has very large capability in terms of computing, in terms of storage, in terms of processing. The other way of looking at it is use large data centers. Now, the concept of data center is that I can build or develop the power of a supercomputer using commodity hardware. Which is a commodity hardware? A commodity hardware is a computer that we can go and buy in the market at a comparatively cheaper cost. A supercomputer is very expensive, but a commodity computer, for example, a workstation, is very easily available, and if we can harness the power of many such commodity hardware to get a equivalent power of a supercomputer, we call this mechanism a clustered data center. As we progress into our cloud computing course, we will see that the strength of cloud is in our ability to be able to build such data centers and exploit these data centers thoroughly, so that we can make our computing facilities available to thousands of users. Now, if we look at the growth of internet connected devices, we see that in 2003, the world population was more than the internet users. The blue ones are the internet users or the devices that are connected to the internet, and the yellow indicates the number of the population in billions. In 2005, we skip that. If we go to 2010, then we see that there is a huge amount of growth in the internet connected devices. In fact, in 2005, as the slide indicates, that this is the year when the number of internet connected devices exceeded the population in the world. And this growth is increasing, and it is predicted that in 2020 a very large 50 billion devices will be connected to the internet, whereas the world population will be 7.6 billions. So, how the internet computing grew is, initially we had the concept of publishing our information in the web. Then we needed to find out how to inform the users, other users, make them aware of what has been published. Then how to interact with users and generate more. And then we learned how to integrate such different published documents or information and make everything more useful. And finally, we learned how to create a transaction out of it. But none of these would be possible if we would not be able to do the other concepts, which is the semantic concept, not exactly the words, but the meaning of the words. Using that, can we discover? So, we have learned how to generate intelligence in our computer and therefore do a discovery. We learned how to make the data intensive world, which is the high performance computing or cloud computing world, automate this whole discovery process. Then came the social media, and by social media I mean Facebook, Twitter, all these, and with that came the revolution of computing and networking, and today we are in the age of data marketplace and data analytics, which is being promoted by the concept of cloud computing. So, let us look at how the paradigms of computing evolved. We started with what was known as a centralized computing. We came then to the age of parallel computing. Cluster computing came after parallel computing or along with parallel computing. Distributed computing came next, and today we are in the age of cloud computing. Let us look at what these paradigms mean to clearly understand what is cloud computing and how cloud computing can help us in doing what we want to do. So, in centralized computing, we had only one central computer, and this one central computer would contain all the resources and will be able to fulfill all our needs. All these resources include processors, memory and other storage, the external storage, and we call this a tightly coupled environment where one operating system will be controlling all the resources. Then came parallel computing, where we can run multiple computations in parallel with each other, thereby of course saving a lot of time. We use multiple processors for parallel computing, and these processors are not individual independent machines, they are part of one single machine. There will be tight coupling between these processors, and typically there will be one single central memory which will be shared among all these processors. The communication between these processors will be using this shared memory, or sometimes it will be using message passing. Then came the concept of distributed computing, where these processors, instead of being stuck in one single machine, now I can use a number of independent autonomous computers. and these computers have their own memory, have their own communication mechanism, but they are connected with each other using a network. Information will be exchanged primarily here through message passing, since the concept of shared memory is not there anymore in a distributed computing. Typically, distributed computing is said to be consisting of multiple autonomous computers, each having their own private memory, and they are communicating with each other through a computer network. Actually, distributed computing is today called cloud computing, with certain other technologies added to the distributed computing, what has become or it has evolved to something called a cloud computing. Then we look at the concept of cluster computing. It is either parallel or distributed processing system, where we connect a number of standalone computers which will cooperate with each other and do one work. So, the goal here is to represent a single computing resource, although it actually underneath has many computers, independent computers connected together. Therefore, from these concepts came the cloud computing, which is internet based, and they share resources, cooperate with each other, and they do a grid like, provide a grid like environment, where the ultimate goal of cloud computing is whether I can provide utility computing. So, in utility computing, what we mean is that the service of computing may be given like an utility to others. Therefore, I need some computing power, I can easily access a cloud and get that. If one user needs some storage power, they can easily access the cloud and get their storage power. This is the concept of utility. In later sessions, we will look into the utility concept in a greater detail. So, let us look at how the cloud evolved. Initially, it was hosting, and then it gave into ASP, and then came the concept of virtualization. With the virtualization came the concept of software as a service or SaaS, and SaaS gave in to what is known as a cloud. So, what is hosting? In hosting, we saw that the applications became more flexible. We can use the hosting power of a server to store our applications and publish it and allow others to look at it. The active server made our applications to be used as a service. The concept of services came along with ASPs, where the applications can be given as a service. Then came the concept of consolidating multiple applications, and therefore, the concept of virtualization. When I consolidate or make third party software available to others in the form of a service, I talk about the concept of SaaS or software as a service. And when we develop the concept of software as a service and virtualization, we came up with what is known as a cloud computing today. So, to understand how cloud is developing or what is going to happen, we need to look at various opinions that people have expressed in terms of cloud computing. Specifically, we are going to look at one particular company called Gartner, as mentioned at the beginning of this session. They have the work of predicting what is going to happen in the world of technology. They have a prediction mechanism which is called a hype cycle, and this is a very useful method of understanding what is happening in our technological field. We will learn what is the hype cycle given by Gartner. So, this is what the hype cycle looks like. Now, we start from, if we see that this x axis is the time and y axis is the visibility of the technologies, and this is the cycle where we have the starting with technology trigger. Any new technology that comes in starts here, and then comes the concept of the peak of inflated expectation. So, what they say that any new technology that comes will climb up the visibility ladder and will come to the peak of inflated expectation. This is inflated because people expect more from a technology, and only later on when things stabilize we can understand what is going to happen. Then slowly it goes down into the visibility, people start forgetting about it, and comes the trough of disillusionment. This is the bottom point from where a technology has two ways to go. It can either go away, leave the space, or it can come to the slope of enlightenment. This is when the technology has developed or is going to develop to become a good technology. Finally, we have a plateau of productivity. This is where the technology becomes into the product. So, then we can talk about that the technology has stabilized and is going to stay. So, now let us look at what Gartner's hype cycle say about our cloud technology. So, in the year 2011, the Gartner's cloud technology, the topmost technologies in the world, has predicted that cloud is at the top of the peak of inflated expectation. So, cloud was going down at that point in time. It was coming towards the trough of disillusionment. This was the prediction made in 2011. Gartner every year comes up with these predictions indicating what are the technologies that are going to remain or where the new technologies are going in the next year. So, if we look at 2012, Gartner said that cloud has started descending the trough of disillusionment and it is going downwards. So, in 2012, with cloud going down, there was a possibility that cloud is not going to survive. So, there was a question that people were asking whether cloud is going to survive the technological innovation or not. So, in 2013, the cloud computing has almost completed its journey and came to the bottom of the trough of disillusionment. And if we move on, in 2014, it has come absolutely at the bottom. As we have already said that the new technology, when it comes to the bottom of the trough of disillusionment, there are only two ways to go for that technology. It can either go out or it can climb the enlightenment path and become a product. So, when in 2014 the cloud technology was at the bottom of the disillusionment curve, cloud started growing, and today in 2015 we can easily see that cloud is climbing in the path of enlightenment. And when the 2015 curve hype cycle will be published by Gartner, we are sure that it will be in the path of slope of enlightenment, and finally it will become the productivity, in the plateau of productivity. Why it is taking so long to make this journey is every technology takes this much of time or much more time to come to the stage where we say that this has become a product and part of our computing. Cloud also is taking its own time, and eventually or slowly it is becoming part of our computing life. So, let us look at a few current leaders who are playing a very key role in the arena of cloud computing. We have here the companies, and then we have the platforms that they are offering, when they have launched, and what are their key offerings. If we look at it, we see that Amazon is a very large company in the arena of cloud. They have, among many things, they have a cloud computing platform called Amazon Web Services, or more popularly known as AWS. It was launched in 2006 and is hugely popular. They offer something called infrastructure as a service. We will learn what is infrastructure as a service a little later in our course. The second company, again a company, very large company called Microsoft. They have their cloud platform that is called Azure. They launched their cloud platform in the year of 2009. They have the .NET and SQL data services as an offering, and what they offer in their cloud is called platform as a service. We all know about the company Google. What perhaps is not so well known to general users is that Google has a very large exposure to the cloud computing platform. They have many offerings. Here we are talking about only one such offering, which is called Google App Engine, or GAE. They launched this in 2008. What they offer is platform as a service as web applications. The last in this list is the company called IBM. They have offered in cloud computing platform their Blue Cloud. It was launched in the year of 2008. It is a proprietary platform which gives the web applications of on-demand web application services. So, we have come to the end of today's session. We have looked at the motivation, wherein we looked at what is motivating us or the world to know and to get into cloud and to do what is required in a cloud computing scenario. Then we looked at the evolution. We looked at the evolution of computing, how the computing has evolved. We looked at the evolution of internet, how the internet has grown out of proportions, and we looked at the various paradigms which came to being from the centralized paradigm to the cloud paradigm. Then we looked at the hype cycle which the Gartner has proposed, and every year they provide a hype cycle indicating what are the new technologies and where these new technologies are going, and we saw that cloud computing is becoming to come to be a very solid and very matured technology. And finally, we saw a few companies who have a high or large stake in the arena of cloud computing. Thank you.